let's start from the technical report released by Google on Gemma 3. So you can see in the model architecture that they have clearly mentioned that we use a group query attention, which was already used in the Gemma 2 as well, but they have replaced the soft capping of Gemma 2 with QK norm. So this is a small change, but the major change was that they have introduced 128K long token as their input uh, tokens. And for that, actually, they have come across the memory challenges. So what does that mean? They used to use a global attention. Global attention means they will consider the entire 128K tokens as a single input, and then they will process that and process the key value pair in the transformer model in cache, and then they will use that for the transformation. So that actually kind of a very overhead to the GPU memory, or whatever GPU you are using for that matter. So for that reason, they have introduced this 5:1 interleaving of local and global layers. So what does that mean actually? So this is so let's say that there are 36 layers in that particular transformer. This is a very simplified example. So uh, the architecture is complex compared to that. So in that 36 layers, then you have kind of six global attention layer and 30 local attention layer. So that's the 5:1 model. It has not been mentioned here clearly, like how they have interleaved those local attention and global attention. That is not there, but uh, uh, we can just assume like that in if there are 36 layers, then out of that 6 layers are global attention layers, and 30 layers are local attention layers. And how they have actually overcome uh, the memory challenges of the KV cache. So they introduced a sliding window for processing the tokens in local attention layer. So what does that mean? In sliding window means they have introduced like a window of 1024 tokens. So let's say that they are now in some tokens, then they will only consider the 1023 tokens before that particular token, and they will calculate the attention of or importance of that particular token with respect to all the 1023 tokens before that. And that way they will proceed through till the end of all 128 tokens, 128K tokens. So that's called sliding window. And for that particular case, like if you are just considering 1024 tokens, then actually you are not using lots of cache for to store the key and value pairs, and that way they're reducing lots of overhead on the memory. So I'll just show you some of the computation graphs they have shown in this paper. So you can see here, let me put it on. So you can see here in this particular graph, this is the sliding window, like 512, 1024, 2048, and 4096 tokens. And then this is the perplexity. Perplexity is prediction capability of the next tokens after going through like all the previous tokens. So if lower the value, if it is 0, then is the prediction capability is much more. So here you can see that they have tested with 2 billion parameters, where local to global attention ratio is 1:1. So that means one local attention and one global attention, which was there in the Gemma 2 model. And then there is another one they have tested, that the local attention, 3 local attentions is to one global attention. And they have done this, and they have uh, found out that the sliding window of 1024 tokens gives the optimum value of the perplexity. Then they have also calculated the impact of that particular local attention to global attention ratio. If they maintain that ratio, then what would be the impact on KV cache memory? So you can see here that if you just have the global attention layer, where actually you are considering all 128K tokens together, so you can see that this is the impact on KV cache memory. If you follow like 1:1 local to global, and the sliding window is 4096, you can see the impact on KV cache has been reduced. Then if you maintain the ratio of local to global as 1:1 and sliding window as 1024 tokens, I think it is slightly reduced, or it is almost same. I'm not sure. But if you just kind of change from local to global, global to local as 1:3, means one global attention to the three local attention layer, then with the sliding window 4096, you can see that it has been drastically reduced, this KV cache memory. And you can see the further reduction of KV cache memory with the ratio of one global to three local attention with a sliding window of 1024, and that's the optimum value. So they have considered this value in this Gemma 3 model. And one more graph I would like to show you that will give a clear idea. So here you can see they have now tested with 2 billion parameters, where local to global attention layer ratio is 5:1, which I was telling very beginning. Like if there are kind of 36 layers, then 6 global attention layer is there, and 30 local attention layers are there, with a sliding window of 1024. And they have compared that with the just 2 billion global only attention layer, just one global only, so all global only attention layer. And with that you can see that this particular parameters, actually 2 billion parameters, with the ratio of local to global 5:1 and sliding window of 1024, the impact on KV cache memory is so less. And if you just use global only attention layer instead of introducing the local only attention layer, it actually increases exponentially. So this is the actually they have kind of reduced the impact on KV cache memory by introducing local to global attention layer as 5:1 with a sliding window of 1024. Go back. So one more thing, as you know that I have mentioned in the beginning, this is a multimodal model. So here they have means this particular model capable of actually analyzing the images with the text, and also this can process the video images as well. Means a small video also I have tested, so they can describe the content of the video. And for that reason, they have introduced the vision encoder. And what they have used, that they have mentioned that we use a 400 million variant of the SIG LIP encoder, a vision transformer trained with a variation of clip loss. The Gemma vision encoder takes as input square images resized to 896 by 896. So this is the important point. Like whatever input you give to Gemma model, that need to be resized to 896 by 896 pixels, and is fine-tuned on data from visual assistant tasks. For simplicity, we share the vision encoder across our 4B, 12B, and 27B models, keeping it frozen during training. So one thing I would just like to mention, so with this particular version of Gemma 3, they have introduced four models: 1 billion model, 1 billion parameter models, and 4 billion parameter models, 12 billion and 27 billion parameter models. And this is so fantastic. Like with 1 billion parameter models, you can also probably run on the mobile devices or small devices. But 1 billion model doesn't support the multimodal scheme of the Gemma 3. It just support the text inputs, but all other models starting from 4 billion to 27 billion, all three models support the multimodal capabilities. Now, they have just not introduced the vision encoder because they have found out there are some challenges with this particular this particular configuration or introduction of vision encoder. And they have mentioned this Gemma vision encoder operates at a fixed resolution of 896 by 896. This results in artifacts when processing non-square aspect ratios and high resolution images, leading to unreadable text or small object disappeared. So with this particular vision encoder, where actually you have to resize the image into 896 by 896 pixel, they have observed that they are not able to read text which is within the image, means, and if it is of high resolution, then those text gets disappeared. Or or also this same thing happens like if these are non-square aspect ratios. So they have handled that as well with the introduction of pan and scan. I'll just read out what they have done here. This algorithm segments images into, so this pan and scan algorithm segments images into non-overlapping crops of equal size, covering the whole image, and resize them to 896 by 896 pixel to pass them to the encoder. This windowing is applied only when necessary and controlled for the maximum number of crops. It is an it is an inference time only optimization and can be disabled for faster inference. So this part is also important. It is an inference time only optimization and can be disabled for faster inference. So that means if you want to disable, so this is by default and it takes some time. Like if you use the Gemma 3 model, you will understand that uh, to process the image and things, it takes uh, more time. And they have mentioned that you this can be disabled for faster inference. So let's say that for you it is probably that image and text quality is not that much important. If you just get an overall idea, that is sufficient for you. So in that case, you can actually suppress this pan and scan method. And what you have to do actually, I don't know whether I'll be able to show you here, but you can write a code by yourself, and there actually you can resize your image into 896 by 896 pixels. And if you do that uh, in your code, then automatically this pan and scan will be disabled, and that will lead to faster inference. So this is all about the major architectural changes. And also one more thing I would like to say, if I get time to show you in the code, I'll show you. So the video encoding actually happens in a way where actually you have to uh, you have to crop that particular video into multiple frames, image frames, and then you have to give that as input to your code, and then finally uh, each frame will be considered as an input, and in that way it will cover the entire video, and in that way it will finally give you the analysis of the video, means what does that video contain. I'll just before I switch on to the user interface demo, I'll just show you the performance of this model which has been mentioned uh, here. So you can see that they have ranked the model based on the chatbot arena, and this is in top 10, the Gemma 327B IT. And you can see that DeepSeek V3 is behind it, which has kind of 671 billion parameters, and where it has just 27 billion parameters. Also, you can see that O3 Mini, that is a reasoning model, O1 Mini, that is a reasoning model from OpenAI. Uh, those are also behind Gemma 327B IT model. And yes, O3 Mini High also behind that. Coin 2.5 Max is also behind that. So with this lesser number of parameters, 27 billion parameters, it has means challenged, or uh, it has won the war of large language model released by several other vendors, and they have used a huge number of parameters. Just to mention that they have also improved their responsibility, safety, and security features of that model. I'd suggest that you can go through this paper. This is available in Google's page. Actually, you can just download this, and you can further go through this paper and understand in detail what they have done for the safety policies, train time, mitigations, etc. I think that's all what I wanted to cover as part of the major architectural changes, and now I would move into the user interface demo. Start with the demo. It is loading the shards into the GPU and restarting the program. Yeah, so I have to just copy this particular link and run. So let me start with one of the image upload. It's one of the trigonometry problem, and so you can see in this problem this is a right angle triangle, and one of the side is 6 centimeter and the angle C is 60°. So my interest would be to know the length of the side AC and BC. I've submitted and waiting for the response. So it has come back with the response. Let me check. So it has started with, here is how to solve the meshing side lengths in the triangle. We have right angle triangle. B is 90 degrees, that is correct. We know the length of side AB is 6 centimeter, angle C 60 degrees, that is also correct. Now find the side BC. And in trigonometry, if you know the tan theta, sin theta, these things, then BC can be calculated as like tan theta is perpendicular by base, which is AB by BC. And let me check. Yeah, it is calculated that way. Tan 60 degrees AB by BC, and then finally they have derived it to 2 square root of 3 centimeter. And similarly, what it has done for side AC is, yeah, perfect. Sine 60 degree is perpendicular by hypotenuse, so AB by AC, that is perfect. Yeah, and AC equal to 4 square root of 3 centimeter. So this is also correct. That's great. So BC equal to 2 square root of 3, AC equal to 4 square root of 3 centimeter. So first question is correct. Let me test it with the tabular data now. Have submitted and waiting for the response. Just to give a bit of knowledge about this particular image, so this one I have taken from one of the spreadsheet where I formulated how to calculate the GPU memory for a specific model, given that if I want to quantize that model into certain bits. So you can see that this is a 5.4 model, and then 14 billion parameters are there. And if I want to use the 32 bits, means without quantizing that model, then I would require 67.2 GB of memory. And if I quantize that into 4 bits, then the memory requirement, GPU memory requirement would be reduced to 8.4 GB. So that type of calculation I did. I just want to check like whether this model can read this information or not. So it has responded back. Let me check. It is a long context. So let's break down the information in the table and understand what it is showing about these models 5.4 and 5.4 multimodal. So first of all, it has properly identified there are two different model name, which is 5.4 and 5.4 multimodal. That's correct. Then understand the columns. Model name. So first of all, it seems correctly identified all the columns. So model name is the first column, then amount of parameters in billion is the second, then amount of bits used for loading model is the third, then original number of bytes for each parameter is the fourth, represent 20%, etc. That is the fifth, and then GPU memory required calculated. So it has actually identified all the columns, and then it has also tried to decipher the meaning of all the columns as well. The name of the language model, this is a key measure of the model size. Then third one is this indicates the precision used to store the model's weight. That is perfect. And so see the beauty of this. So it has just not simply analyzed the data, it has also derive tried to make some sense out of this image, all the text, what does it mean, etc., etc. It has tried to understand the relationships between all the columns. It's fine. 32 bits models require significantly more memory than for 4-bit models. For example, 5.4 14 billion parameters in 32-bit precision needs 67.2 GB. So this is talking about the first row, 5.4 14 billion parameters with 32 bits, 32-bit precision mode, it requires 67.2 GB, while the same model in 4-bit precision, that the second row, 4-bit precision, needs only 8.4 GB. See how beautifully it analyzed and then related uh, the context between the rows as well. Then the multi-model versus standard 5.4. The 5.4 multi-model model generally requires more memory. Okay, then it has tried like calculations, how the GPU memory required is likely calculated. So see, this is the final result, and these are all the inputs being used to derive into this result. The logic is not given here, but it has tried to derive the logic based on all the given informations, and with that logic it has tried to also calculate the GPU memory. And it see, for the first row it has said 2.15 GB, which is definitely wrong because it's given 67.2 GB and could not calculate it properly. Okay, then I think it tried to print something else as well, but this got disconnected because I have limited the number of output tokens to 800, so that's why. Anyway, so it seems like it has properly tried to analyze the image, it has tried to relate the rows but it has also tried to derive the logic in which it has been calculated, but that derivation has gone wrong, it seems. But anyway, my I was not expecting it to derive anything for me. I just wanted to check like whether it is able to read the tabular data or not, which it has read perfectly, it seems. Now let me try with some other image as well. So before that, I'll clear out whatever information is there. So now I'll give this image and I'll ask it whether it is able to analysis or not. Okay, let me submit this. It has come back with the answer, and let me see what it has given. This is a classic silly meme. Here is a breakdown of the humor, the setup. The first two texts establish a concern. Someone notices the person acting differently and asks what is on their mind. That is correct. The punchline, the response, short giraffe, and the accompanying image of a giraffe with a noticeably short neck is completely nonsensical and unexpected. It is a non sequitur statement that doesn't logically follow the previous conversation. The humor comes from the absurdity of the response. It's funny because it's so random and doesn't address the original question at all. Yeah, it has perfectly analyzed the image and responded back that this is a humor, and it has analyzed every text within this image. That's great. Let me see if I have anything else to check here. Okay, so here comes a specific word is written in multiple languages, and let me submit and I check like whether Gemma 3 is able to actually label this image or not. Let me submit it. It has come back with the responses. Let me check. So first one is Arabic, then Armenian, then Georgian, or Tibetan. Let me check it from here. Arabic, Armenian. This is not correct. This is Atlantean. What it has told. Georgian, and this one it has mentioned as Tibetan. It doesn't seem to be correct again. The second row is Tamil, and envelope symbol. Okay, this is correct, but this is definitely not Tamil. This is the Bengali word. I know that for sure. And sixth and seventh. No, that is also not correct. I think no, I don't know what it has done. No, I think up to certain words it has translated correctly, but after that it has messed up. So there might be few reasons for that. Maybe I have given a lot of words in different languages in a single image. That might be the reason. If I would have given probably one, if I would give, I would have given an image with one specific language, then might be it could correctly identify that. But here I think in A lot of cases it has gone wrong. Even it has identified even wrong word from the image. So anyway, means at least it has started with the correct thing, like the Arabic word and then Armenian word that has been picked up correctly. Then I think this image specifically, I think it is not similar to the third word, and then same for the fourth one as well. The second row, this word, I don't know where from it has picked up. Maybe it has picked up some correct, but second row first word is not that one definitely. So that is Bengali word. Anyway, let's. I would say that it has tried correctly. Maybe I have given some difficult images to process. So no worries. I'll let's try with some of the video clips so that it is able to understand or not. So this is a video, and let me submit it. I'll definitely play this video after it gives the answer. So I have pressed the submit button, and I'll be waiting for the response from Gemma. So it has come back with the answers, and let me see what it has given. Okay, let's analyze the. So if you remember, if you have gone through the architectural part, which I have started initially, which I have started with in this particular video, there I have mentioned that whenever we give a video image, video clip actually, it tries to break it down into multiple frames, and multiple frames save that as an image, means I save that as an image, and then it tries to read the images, means images of all the frames of that video, and try to analyze each of them, and finally consolidate and find out the summary of the video. So you can see here, like it has given some of the frames, and then it has described what those frames have actually. The blue tit is initially paused on the camera, seemingly investigating it. It's mostly facing away from the camera. The bird starts to turn its head, looking more directly towards the camera. It seems curious and perhaps a little cautious. Then the third frame 14.45 to 17.35, the blue tit is now facing the camera more directly and appears to be looking at it. It's a good opportunity for a clear shot. Then the last one saying that bird is now fully facing the camera and seems to be looking directly at it. It is great opportunity to capture a portrait of the bird. Overall impression is it is a charming sequence showing a bird's interaction with the camera. The time-lapse format highlights the bird's movement and curiosity. It is a lovely example of wildlife photography. Now I'll play the video and see whether it matches the description or not. Yeah, it is curiously looking, and it has some movement as well. It has gone away, come back again. Perfect. I think this analysis was perfect, 100 out of 100. So anyway, just to summarize, I started with probably one trigonometric maths questions, and let me check again. Yeah, so it has analyzed it correctly. It has given the answers also, which I didn't ask even, but it has given the answers. Then second one was that I gave it a tabular data, which it tried to actually, it has, I didn't even ask it to provide me the formula which have been used in that spreadsheet, but it has tried to actually derive the logic to calculate the answers, which for some reason it has derived wrong. But anyway, my intention was not that whether it can derive that logic or not. My intention was that whether it can read the value or not. So I have confirmed there that it has correctly read the value and even tried to give the answer as well based on my question. And the third one which I did, uh, I gave it one single word in multiple languages in an image. So it started with correct uh, information, but after that, after first two, it started giving wrong information. So I believe somehow it has gone wrong somewhere. I'm not sure where it is, but probably if I could give it as a complete text in a specific language, it would have done probably better. But I think in this case where multiple words in same word in different languages is given, it got a little bit confused probably. And the fourth one was a video clip which it has perfectly analyzed and given a concise impression of that, so where I can give it 100 out of 100. So this is a uh, this was a really uh, nice work by Gemma 3, and it has very good ability to analyze the image, even good mathematical problem solving capability, and also the good video quality analyzing. I'll go to the code part and I'll try to explain as much as possible there now. Start with the code demo, and before that we have to understand that uh, the packages required to run this particular code. So it is obviously torch, and then the transformers from the Hugging Face, and you can see this is a tagged with like specific version, and the specific version named as Gemma 3, and then accelerate, numpy. Papt is not required for some reason, it has stayed here. And then Pilo and OpenCV Python, these are two image related libraries, and Gradio is related to user interface. So I'm importing Gradio, then transformers. From transformers, I'm importing autoprocessor and Gemma 3 for conditional generation. Then I'm importing CV2. I'm importing image from payload, then OS, NumPy, Torch, and UUID and things. Then I'm using here the Gemma 3 with 12 billion parameters, and this has almost consumed my 24 GB GPU memory space. This is without quantization as well, and that might be one of the reason it was taking more time to actually infer the data, infer the response. There is one more reason, might be because, as I mentioned in the beginning of my video, where I have mentioned that it does pan and scan methodology to infer the best quality out of the image analysis, which takes time to infer. So that might be one of the reasons it was taking a little bit of time, a little bit of more time. So anyway, this is the 12 billion parameters model. I could also use like 4 billion parameters and 1 billion parameters as well. Then it is using the Gemma 3 for conditional generation to get the model, and then finally it is also initiating the processor. So this is the media directory. This is just being space to upload the media, and it is creating that particular directory here. You can see that this is the media directory within this particular environment. Then save image and save frame are two functions where actually we are using this to save the image, whatever it is getting generated, and save the frame. Frame, I have mentioned that earlier, if you remember, like whenever we are giving video as an input, it is cropping that video into multiple frames, and then each of the frame it is save as an image, and then finally it is trying to analyze the individual images or frames, and then finally it is summarizing the outcome and producing that as a output of a video analysis. So this is the where the frames are saved, and then this extract frames, this particular part actually called to extract frames from the video, as I was explaining a few seconds back. Like every video will be cropped into multiple frames. So we have used the CV2, that is a library, and in that taken help of that library to get the total frames, calculate the total frames, and based on that we have tried to divide it into number of frames, and finally we are returning that number of frames of that particular video generated from that particular video. Then finally this is the generated response. This is the main function where actually I am taking the full chat history along with the text input, image input path, and video input path. So you can see here, like this is a content array, and first I'm checking that whether there's any text input or not. So I'm checking whether there's a text input or not, and you can see that this content.append actually is taking a dictionary where the type I have mentioned the text. That means this is a text input, and what does the text have? That is a text input which is coming from the user interface. Now if that is the image input path, so at a time I'm considering only one input, so not all the inputs, though I'm capturing everything within the chat history, full chat history, but as the input I am not processing all the input together. That's why probably you might have noticed that every time I was giving an input, I was just clearing the previous input and giving a new input. So at a time it can accept only one input, and it is calling the save image function, which I shown you in the top. So it is saving the image in the specific path, and finally it is also creating a content.append, and where it is mentioned that the type is image, and then the image is the path of the image actually. Similarly for video input also, it is calling the extract frames, where I'm getting the frames, the frame details, where actually it has segregated the video into multiple frames, and then I am just going through each of the frames, and I'm creating a prompt for each of the frame, like the type is text, and the text contents like frame and timestamp, and then the image means each of the frame type is image, and that image within the image tag I have pushing the frame path. Now finally this is the new user message. This is common for all three different type of inputs, text, image, and video, where I'm specifying the role is user, and content is whatever content it is getting generated from the top, and updated full chat history. Now after getting that response, getting that input from user, I'm just appending that input from user with the full chat history. You can see that full chat history is coming to this function. And then processor, which was initiated here actually, this processor is being called here to
So this apply chat template from the processor is being called here with all the information like updated full chat history, and these are some of the parameters which I'm passing here. And then finally I'm just using that this need to use the GPU here, and it is converting that into as a model inputs, this particular function. And once you get the model input, so model inputs is now complete full chat history along with the recent questions or recent query or recent informations. So these inputs need to be passed to generate some outputs. So here I'm doing the same thing like with the torch.inference mode, using the model which was defined earlier to generate the values for that. And this is having this inputs as an input here. And max new tokens equal to 800, so you can describe it as you wish. So if you remember, like in one of the response to the tabular data, the response was kind of, it looked like the response was unfinished. So if I probably could give more values here, then I would have probably received a complete response. So anyway, it depends upon your use case, where you know that maximum 800 tokens is fine, then you can just define that as 800. But if you expect that, okay, that is not enough and you might need to generate more tokens or more outputs, then probably you have to increase this particular value. And then finally, you are calling processor again with the decode function, and you are providing these informations and want the model response back. And finally, you can see that assistant message, then the prompt is role is assistant and content is type text. And what does the text content? That is a decoded message from here, that is a model response. And this is finally appending this particular message to our updated full chat history, which was there with the question earlier. Now we're appending that with the response. And yeah, this is finally the so this is finally returning the display history and updated full chat history to these Gradio blocks actually. So this is a Gradio blocks. If you have noticed that the top left corner was like multimodal chat demo, then if you have seen, this was the text message was there on top of the interface. And then finally this is the different text input, image input, information which is being defined here, that user interface. And finally on click submit underscore button dot click, whenever you submit that, then it is calling generate response, which was the function here, the generate response. It is calling that, and the inputs, it is getting full chat history. So this is the inputs these are the inputs to this function generate response, and these are the outputs, that is chatbot and full chat history. So this is all about the coding part of this particular demo. And okay, one more thing I just want to mention. If you remember during the initial part of the video, when I was explaining the architectural changes, I mentioned that for pan and scan logic, it takes some time, because it tries to feed that information, feed that image, feed any image you give, it tries to feed that into 896 by 896 pixels. It do some more work there, and then it tries to infer the response back. And that's why it takes a little bit more time compared to any other model. But if you want to get a faster response, then you don't have to depend upon that, and you can probably, what you can do, you can, whenever you are getting image input path, you can call one more function where you simply uh, resize that image into that 896 by 896 pixel, and then uh, send it into the prompt. Save that and send that into the prompt. In that way, you can actually instructing the algorithm that not to use pan and scan. I'm resizing, so that is sufficient. In that case, pan and scan will not be initiated, and you will directly you will get faster inference compared to the pan and scan logic. So that's all for today's demo, and hope you have liked it. Feel free to put any comments on this video. It seems like a little bit lengthier, but I hope that this makes sense actually. Uh, and if you have any questions or if you have any suggestions, please feel free to put down into the comment. Thank you.